Very good morning, everyone. In the previous class, we discussed how Linux manage process, memory, and files. Today, we will see how Linux talks to hardware, protect itself, and what exactly the kernel is. Okay. Okay. Let me ask you a very simple questions. How does your computer know when you pass a key? How does printing happen? How does your system stay safe? The answer is very simple. All this is handled by Linux quietly in the background. Okay, let me share my screen with you all. It is visible. Okay, so what are input and output devices? Anything that sends data into the computer is an input device. Anything that sends data out is an output device. Keyboard is your input device, mouse is your input device, printer is output device, and hard disk is both input and output device. The operating system controls all devices. User never talk to hardware directly, right? You don't talk directly to the electricity department. You just use a switch. The OS is that switch. Okay, what is IO management? IO management means controlling the flow of data between user and hardware. Linux decides when data goes, where it goes, how fast is it goes. Okay, if everyone tries to print at once, what happen? Yeah, there are lots of chaos, lots of chaos. Linux organizes this neatly. Okay, what is buffering? Buffering means temporary storage. When you type fast, letters appear smoothly. They are first stored in a buffer. Caching means storing frequently used data. Recently opened files open faster, right? Keeping data, keeping daily use items on your disk, that is caching. Example of an caching. Spooling means queuing jobs. For example, many people give print commands. Linux makes a line. Token system at a bank, it's a very good example of spooling. What is a device driver? A device driver is a translator. Linux does not understand printer language. Printer doesn't understand Linux language. Driver translates between them. Like, for example, printer driver, keyboard driver, Wi Fi driver. Without drivers, hardware is useless. What is system protection? So, system protection means one user should not disturb another user. Student should not access a teacher's files. It's an example, right? So, Linux ensures proper access and limited permission. Security means protecting from viruses, protecting from hackers, protecting personal data. So here Linux uses users and password, permissions, firewall, updates. What are the examples of attack? See, a virus, it's a harmful software. We know. DOS attack, too many requests at once. Okay. Another one is identity theft, that is stealing logging details of someone. Okay. How Linux prevents attackers? So, देखिए, Linux prevents attackers by strong file permissions, secure login system, firewalls, regular updates. For example, locking doors plus CCTV plus security guard, right? At your home, you will be secure by locking doors plus CCTV plus security guards. Linux is considered more secure because users don't get full power by default. What is kernel? The kernel is the brain of the operating system. It connects software to hardware. Without kernel, no keyboard, no memory, no programs. Kernel manage memory, manage process, manage devices, decides what run and when. Like kernel is like the central nervous system. Okay, why a good kernel matters? A good kernel gives faster performance, better security, stable system. For example, good manager is equal to smooth company, right? And bad manager is equal to confusion. So that's why good kernel matters. So today we learned how Linux manages devices, how it controls data flow, how it stays secure, why the kernel is the heart of Linux. So Linux works silently, but without it, nothing works, right? Here you can see IO means input output communication between user, program, and system. Uh, I give you example of inputs like a keyboard, mouse, file input, and output devices like printer, monitor, file outputs. So in Linux, everything treated as a file. Okay, keyboard, hard disk, printer, these all are files. Okay, everything in Linux is a file. So Linux has three standard streams. Like standard input is stdin and its number is 0. Standard output is std out, its number is 1. Standard error is stderr, the number is 2. Okay. Output goes to std out and errors go to stderr. Linux allows redirecting output. Okay, just type ls space file dot txt. See, Linux, there are some Linux security fundamentals also, like user-based security. Linux multi-user system are like root user, that is super user, normal users. Root has full control, command to switch users. There are file permissions also. There are three types of file permission, like read, write, execute. Three permission groups: owner, group, others. Okay, they are decided what to do. Like owner are permissible to write, read, write, and execute. Group are permissible to read and execute. Others are only permissible to read. Okay, you can change permission also. There are some authentications also, like Linux uses username, password. Okay, password are stored in command like slash etc slash shadow, which is in encrypted format. Linux uses firewall also, like IP tables, UFW. Firewall protects system from unauthorized network access, as you know. Okay. See, kernel is the heart of Linux, heart of the Linux OS. It acts as a bridge between hardware, software. Without kernel, system cannot work. See, Linux uses monolithic kernel. See, Linux uses monolithic kernel. All core services run in kernel space. There are some main function of kernel also, like process management, creates process, schedules CPU, handles multitasking, memory management, allocates RAM, manage virtual memory, swapping, file system management, like handled files and directories, support file systems like ext4, device drivers, like communicates with hardware, keyboard, mouse, printer. There are some system calls also. System calls are interface between user program that's that tends to kernel. For example, open, read, write, fork. Okay, kernel space versus user space. So kernel space give you full access and user space are having limited access. Kernel space give you a hardware control, otherwise uh, on the other hand, user space are where application runs. Kernel space are more secure and user space are isolated. How everything works together. First, okay, user types command, shell sends request, kernel process request, hardware respond, and output shown. Right? I repeat, how everything works together on Linux. First, user types command. Second step is shell sends request. Third step is that kernel process request. Fourth step is that hardware responds, and then final output is shown. When you type shell cat file dot txt, shell call system call, kernel read file, and output sent to terminal. See, Linux is a powerful tool, powerful operating system because of its strong kernel architecture, secure permission model, and flexible IO system. Understanding these fundamentals help you build strong knowledge in system programming, system performing, cybersecurity, and operating system. Okay, so before moving to the next section, we have some question answer session. As I always tell you some important questions on based on the above lecture. So let's start. Okay, moving to the session, which is input output device session. And the very first question of this session is what are input output device? A very simple question, guys. Very simple question. Input output device are hardware used to send data to and receive data from the computer. Okay. Second question is give example of input devices. Give example of input device. Yeah, simple keyboard and mouse are common input device. Give example of output devices. Monitor and printer are output device. Who controls input and output device in a computer? Yeah, the operating system controls all input and output devices. Next question is, why does the OS manage IO devices? To ensure smooth communication between the user and hardware. Okay, coming to the next section, IO management. Okay, the very first question of this section is, what is IO management? What is IO management? IO management is the process of controlling data transfer between hardware and the system. Okay, next. Why is IO management important? Because it helps devices work efficiently without slowing down the system. Next, what happens if I/O is not managed properly? Yeah, the system may become slow or unresponsive. Next, does the user directly control hardware devices? No, the OS act as an interface between the user and hardware. Okay, section 3, buffering, caching, and spooling. So the very first question of this section is, what is buffering? Buffering temporarily store data while it is being transferred. Okay. Next, why is buffering used? Because it helps data speed differences between devices. Next, what is caching? Caching stores frequently used data for faster access. Okay. Next, why does caching improve performance? Because data can be accessed quickly without repeated loading. Next, what is spooling? Spooling stores jobs in a queue to be processed one by one. Okay, next, give a real life example of spooling. Yeah, I told you earlier the example of spooling. Can you remember? Yeah, example of spooling is print jobs waiting in a printer queue. Okay. Okay, next, let's move on the next section, that is device drivers. So the very first question of this section is, what is a device driver? A device driver is software that allows the OS to communicate with hardware. Okay. Next, why does each device need a driver? Because different hardware works in a different way. Next, what happens if a driver is missing? The device may not work properly or may not work at all. Okay. Next, who provides device drivers? Hardware manufacturers usually provide device drivers. Okay, moving to the next section, that is system protection and security. So, very first question of this section is, what is system protection? See, system protection restricts access to system resources. That's it. Okay, next. Why is system protection important? Why is system protection important? Because it prevents users from interfering with each other's work. That's it. Okay, what is security in Linux? Security in Linux protects the system from threats and unauthorized access. Okay, what are common security threats? Viruses, hacking attempts, and identity theft. Okay, next, what is a virus? A virus is a harmful software that can damage files or systems. Okay, next, what is a DOS attack? A DOS attack floods the system with requests to crash it. Okay, it generates lots of requests, a flood of requests. Okay, with the aim to crash the system. Okay, let's move on the next section, that is how Linux prevents attackers or attacks. So, a very first question of this section is, how does Linux protect against security threats? Yeah, you know the answer because I am very much repeating. By using permissions, firewalls, and user authentication, right? Next, how do file permissions improve security? They control who can read, write, or execute files. Okay, next, why are regular updates important? Because they fix security issues and improve system safety. Okay, that's why it is important. Next, what role do password play in security? The answer is passwords prevent unauthorized access to the system. Let's move on the next section, that is kernel, the heart of Linux. Okay, so first question of this section is, what is the kernel? The answer is the kernel is the core part of the operating system. Next, why is the kernel called the brain of Linux? Because it controls memory, process, and hardware. Next, what are the main functions of the kernel? Managing process, memory, and devices. Next, how does the kernel connect software and hardware? Yeah, it act as a bridge between applications and hardware. Next, why is a good kernel important? It is important because it improves performance, security, and system stability. Okay, next. How does Linux improve system performance? By efficient IO management and kernel control, right? Okay, next. Why is Linux considered secure? Because because of strong permissions and kernel level security. Okay, next. What happens if the kernel fails? Yeah, the entire system may crash. Next, why should students understand the kernel? Why you should understand the kernel, students? Tell me. Because it helps you to understand how operating system works. Okay, next. Is the kernel visible to the user? No, it works in the background. Okay, next. What is the biggest strength of Linux OS? Biggest strength of Linux OS is its stability, security, and efficiency. Okay. Uh, See, Linux security is Linux is famous for its security. Okay, because here root is like a god mode. Linux has a super user called root, and root can delete entire system, change passwords, stop services, modify kernel. So that's why normal users are restricted. And there are some very interesting facts about Linux, which I told you that Linux rarely needs antivirus. Okay. Yeah, Linux rarely needs antivirus because it has its own strong permission system, limited admin access, open source auditing, fast security patches. That's why most servers prefer Linux. And permission system is genius because every file has owner, group, others, and permissions are read, write, execute, as I told you. Okay. If you are a owner, you have full control over it. If you are belong to the to any group, the access permission is limited. And if you other belong to others, you can only read the files. The small design prevents most attacks. Okay. Here, passwords are encrypted. Even system admin cannot directly read original password, right? And Linux has military level security. Okay, SE Linux was developed by National Security Agency, and it had mandatory access control MAC. Even if a hacker enter system, SE Linux limited damage. It is used mainly in Red Hat Enterprises Linux. There are some another facts like kernel never sleeps. You can say that kernel never sleeps. Even if no application is running, kernel is managing memory, CPU scheduling, hardware interrupts, device communication. Okay, Linux uses monolithic kernel, means all core services run inside kernel space. It gives high performance and fast execution. Kernel handles multitasking smartly when you open browser, music, terminal. Kernel decides which process gets CPU first. This is called process scheduling, as you know. Here, system calls are secret doors. Applications cannot directly talk to hardware, they must use system calls. like open, read, write, fork. This keeps system secure. There are some another facts like kernel updates without restart. It's a very advanced feature of kernel. Its kernel. Okay, means kernel updates without restart. Some Linux system supports live kernel patching, meaning that means you can update kernel without reboot. So big companies love this feature, right? If I take you in a real life example, so imagine that Linux, here are some Linux parts, and I will give you a real life example to connect with. Like kernel is like brain, shell is like translator, input output is like mouth and ears, security is like lock and key, and root is like king. Okay. See, Linux is powerful because not because it looks beautiful, but because it is designed intelligently, and its input output system is flexible. Its security model is strong, and its kernel architecture is highly efficient. That's why Linux dominates servers, cloud computing, and cyber computing field, cyber security fields. Okay, when you press a key, like keyboard to device driver to kernel to shell to output, okay, it goes to keyboard to device driver to kernel to shell to output. That means every input output request passes through the kernel layer. This control design makes Linux stable. Here are some buffer cache magic also. Like when you open a file, Linux store it temporarily in RAM. Next time you open same file, it loads faster. Okay, this is called buffer cache or page cache. You often don't realize Linux optimizes performance automatically in the background. Okay, here everything is stream based. Linux treats communication as a stream of data, even network data, file reading, keyboard typing, everything flows like a data stream. And that's why Linux is powerful. Okay, Linux is powerful for data processing, machine learning pipeline, log analysis. Linux also uses DAC and MAC. DAC is for discretionary access control, means user decides permission, and MAC is mandatory access control, that is system enforces a strict policy. C Linux provides MAC. I told you, which is developed by National Security Agency and used in Red Hat Enterprises Linux. There is a special permission called SUID, set user ID. It allows a normal user to execute a program with root privilege temporarily. For example, PASSWD command, even normal user can change password because it runs with root authority. This is powerful but risky. Here, Linux supports containers. For example, Docker. Containers isolate applications. Even if one app crashes, others remain safe. This isolation is kernel level features. So basically kernel is not just a program, it is the system controller. Okay. And at the end, I just want to conclude this. Linux is not powerful because it is free. Okay, Linux is not powerful because it is free. It is powerful because of intelligent kernel design, secure permission architecture, and flexible IO model. That is why Linux dominates cloud computing, cybersecurity, AI server, and research environment. Okay, that's it. Let's move on the next section. I will end it here.